Hello, everyone. I'm Jovana from MDPI, and I will be your host for today. Welcome to the webinar, Crop Evapotranspiration, Innovative Approaches in Calculation, Application in Practice, and Water Saving. Before introducing the MDPI Journal Water and lineup of today's event, I would like to remind everyone that this webinar is being recorded and the recording will be made available as soon as possible on the webinar webpage. Please note that you need to be logged into the site forum in order to see the recordings. A pioneer in scholarly open access publishing, MDPI has supported academic communities since 1996. Based in Basel, Switzerland, MDPI has the mission to foster open scientific exchange in all forms across all disciplines. Our 489 diverse and open access journals, including 480 peer-reviewed journals and 9 conference journals, are supported by more than 295,000 academic experts who share our mission, values, and commitment to providing high-quality service for our authors. Water is a peer-reviewed open access journal on water science and technology, including the ecology and management of water resources, and is published semi-monthly online by MDPI. Water collaborates with Stockholm International Water Institute. In addition, the American Institute of Hydrology, the Polish Limnological Society, and Japanese Society of Physical Hydrology are affiliated with Water, and their members receive a discount on the article processing charges. We are indexed in Scopus, Web of Science, EI Compendex, GeoBase, GeoRef, and other databases. When it comes to journal rank, we are ranked in Q2 category of water resources and Q1 category of aquatic science. There will be 4 presentations today, or 20 minutes each. The presentations are followed by Q&A session moderated by webinar's chair. If you are interested in submitting your research to a special issue that is linked to this topic, please visit our website for more information. In case you have any questions for speakers, feel free to post them in Q&A box. You can find it in the Zoom menu bar at the bottom of your screen. It would be great if you could post your question there and not to the chat. Today's webinar is chaired by Professor Dr. Luis Santos Pereira from University of Lisbon. Professor Pereira is Professor Emeritus of University of Lisbon. He obtained his PhD degree from the Federal Institute of Technology in Switzerland. Director of research projects in Europe, Asia, and Latin America, and consultant of Food and Agriculture Organization of United Nations, mainly on irrigation, evapotranspiration, and vegetation water use and water scarcity. He is co-author of Food and Agriculture Organization of United Nations Irrigation Drainage Paper 56 on guideline for crop water requirements with more than 40,000 citations. He is also member of Scientific Professional Academics of Portugal, Italy, France, USA, and others. He is a recipient of numerous awards from China, Egypt, India, Italy, Mexico, and Spain. He authored or co-authored more than 400 papers in journals and books. So that will be all from my side for now. I would like to thank you to Professor Pereira for chairing this webinar. That was all from my side. Now I will hand over the floor to the chair.
So I am pleased to be sharing this webinar on crop evapotranspiration and innovative approaches in calculation, application, and water saving that is resulting in the new FAO Irrigation and Drainage Paper 56. Move. Next. these guidelines are nearly read, but not yet read. And the authors are those sharing this webinar, plus one edge officer, Meyer Salman. Please move. Okay. The four authors go to present different subjects that are common to all of us, but I just gave an overview and explain to you that we have about 50,000 citations of the original 456. So with these, we create a lot of new knowledge that is included in the presentations. Rick Allen will speak about the reference CT with the special focus on the quality of observations, the accuracy of calculations, and the better approach to the case when weather data are incomplete. Paula Perez will speak about particularly on crop coefficients, their accuracy, and the new use of thermal time to define the curves, and the most innovative set of information referred to fruit trees and vines and shrubs that will be presented by the colleague Ramon Lopez Urrea. Please. Yeah. Basically, the definition of crop evapotranspiration used by FAO since some 40 years is kept. It means that the crop evapotranspiration is the product, computed as the product of Kc, a crop coefficient, by ETO, the reference evapotranspiration. But we don't just use this definition. We define like that only from the weather parameters the reference evapotranspiration or reference gas evapotranspiration. We define ETC by this product, so it is the standard. It is standard crop coefficient and the standard crop evapotranspiration at today's date, and the actual value that is different from the maximum yielding value. Please. Essentially, some 35 years ago, we find out a definition common to many people on the reference evapotranspiration from grass as reference crop. The big question is that this is a definition that is not represented by anything in the field, but it is just computed with weather data. And if it is, and it is like that, being like that, we define, of course, the aerodynamic resistance and the surface resistance. This surface resistance has been a little bit modified because this is just for the day. Please, Giovanna. And we have now different resistances. 70 seconds per meter for daily time steps, 50 seconds per meter for hourly time steps, and 200 seconds per meter for nighttime hourly time steps. Of course, these equations are fully adherent to the reality, despite we are not proving it in the field, but just theoretically well funded by the physics of the evaporation. Please, Giovanna. There is a problem, of course, because in many places of the world, there are not enough observations, and some variables are not observed. And it is necessary to find out replacements. And these replacements correspond to the so-called PMT method, or it is Perman-Montis temperature, PMT, and corresponds to this kind of flux diagram. This is published. This is proved through publishing, but we hope that you can prove this and make us to correct something if necessary. Giovanna, but so being observed, so we gave big attention to the quality assessment, quality control activities, and here is example one from Davis, California. You can see for the solar radiation, here the observations are far away of the theoretical value, and here they are corrected. Here there is a profusion of complications during 5 years, and this can show that we cannot live with relative humidity with this kind of nonsense variability. Please, Giovanni. We keep giving a big importance to the KC and KCB curves. Means everybody knows what is this, and we insist that these curves are represented by an initial value, then they grow from the initial value during crop development, then they are in average stable during mid-season, and then they decrease until the end of the season, of the late season. But we insist is that we don't need to have equations, new equations for this. We want to have is a good representation of the crop that is in the field. Please, Roman. Here you see examples where here you have KCB, here you have KC, and of course KC, that is KCB plus KE, that is the coefficient of soil evaporation, are providing about the same value. Of course, it is necessary that the observations are well done, as it is the case represented here by that was developed by Ramon. Please move. But we have seen in this picture that from 2008 to 2009, the curves were different, but the values were the crop coefficients were the same, but the duration of the periods were different. Therefore, instead of measuring the duration in days, we have to represent this by the thermal time. And you can see here that when representing the thermal time, you have here in Otao, near Mongolia, in Inner Mongolia, Coruche in Portugal, that the duration in days for the same crop coefficients is very much different. The same thing when we go to the southern hemisphere, and of course, the planting is starting in the left side, in the right side, instead of the left side, and you can see that the same type of variation in days occur. And so we have much more facility to be close to truth. We will not have the truth anyway, but maybe for one measurement, but not more. Please. These 30 years or 35 years of observations, so since 98, led to many studies that derived the KC and KCB. We selected those that correspond to define a way of observation in field and calculation. And you have here for the annual crops, and you can see that it's different, these titles on the top, very different from what is in the for the three crops, or for the planted grasslands, or for the natural wetlands. So it means that we enlarged very much the panoplia of crops, and we provide in the facilities for computation for all these type of crops. Please, Vanna. Of course, we can compute from data many things. And one way commonly used is the ecovariance, And the other is soil water balance. And of course, others are less used. But and for using the soil water balance, we define two things. What is the influence of salinity on the movement of water, and what is the influence of salinity on evapotranspiration? For both non-saline and saline, we develop much the computation of the different please move of the different processes. Here you have the variation of the process of capillary rise for different conditions of the water table depths, and you can see the influence of water table very well through the different curves. So there is no reasons, please move, for using other methodologies that are less good. We developed the actual KCB for irrigation scheduling as a consequence of the density of the crop, and this density is defined from the crop age and the occupation of the territory by the crop, and of course by the expected values of Kc for the crop. And then we compute a KCB. Please. Okay. And you can see that using this, for the case of a very pristine crops, here in this case, onion and tomato, we have a very good comparison between the KCB from lysimeter and KCB computed with that equation. We call it A and P because it is Allen and Pereira. The tomato is the same thing, and it was computed with the soil water balance. Move. This approach modified also our way to compute Kc and Kcb for fruit trees and vines. Dr. Ramon will show you this more in detail because we consider now not the Kc for, let's say, apples, but we consider the density of apples, all the ground cover, the height of the crop, how it is the training system, and this permitted to have a much more objective computation of Kc and Kcb standard from the data observed by many people, many researchers. Please. Here it is the example, one example of the parameterization of this A&P approach. In this case, it is made for vegetable crops. And you can, all this information is nowadays included in the FAO 56 new. Okay, the question is very interesting, is that any user can modify all parameters for the conditions they have in field and find out what is their own actual KC. Of course, this has been computed for the standard KCB because only standard KCB values can be transferred from one field to another. Please. The basal KCB for the woody crops is an example here with olives and another with table grapes, show you that we now have another specification. So we don't say that it is a young olive. We say what is, how many years intensive, is this edge row, is this not edge row, and so on and so on. So we believe that we approach reality much better, but the user has to take care in computing with consideration all these factors. So he is required to observe much better in field. Please, Giovanna. Okay. And finally, the new guidelines discuss different strategy, methods, and technologies that can be used to water saving, and of course, how the computed ETC can be used for appropriate assessment of water requirements aimed at water saving also. Thank you very much.
Thank you, Professor Lewis, for your presentation. I will now introduce our second speaker. Just let me know. Our next speaker is Professor Dr. Richard Glenn Allen. Dr. Richard Allen has 40 plus years of experience in evapotranspiration measurement and calculation and irrigation technology. He has been a pioneer in developing surface energy balance determination by satellite and is the co-developer of the metric EE flux and EE metric processing systems. Allen has applied the metrics process to a wide variety of application areas, including 30 USA states and 8 countries. Professor Richard has taught university courses and training workshops on irrigation design, hydraulics, hydrology, evapotranspiration, micrometeorology, and surface energy balance processes. He has published more than 117 papers and has an H-index of 81. He was the lead author of the 1998 edition on publication on crop evapotranspiration. Professor Richard, if you're ready, you can start with your presentation.
Well, it's a pleasure to be with everyone and to finally see the revision coming to completion. So we hope that everybody enjoys it and finds it useful and even more useful than in the past. I'll talk a little bit about just the reference ET, a few things that have changed or evolved. primarily now we emphasize perhaps more than before the use of hourly time steps, since they are becoming more prevalent with many of our automated agricultural weather stations. And as Louis indicated already, the need to make sure that our weather data represent an agricultural situation where we have cooler air and more humid air, and the need for quality assessment, as Louis indicated, and then just a few statements on gridded weather data sets. Louis already covered these. Basically, the hourly and daily equations are exactly the same, with the only difference in coefficients to account for the length of the time step and the smaller surface resistance for the hourly time periods. Here's just an example from Davis, California, of calculating reference ETO using a daily time step on the vertical axis versus calculating it hourly and then summing it over 24 hours. This is over a 5-year period, and we can see very good consistency between the two time steps. So the conclusion is it doesn't really matter which time step you use. If you have hourly data, we encourage its use, especially as we note in the bottom here. If one is in winter periods in extreme latitudes, the days are short, and hourly data can help us to keep the solar radiation, humidity, and wind speed synchronized with each other. And that can be quite important for making good estimates of ETO wintertime. There are many methods and applications around for calculating ETO. A lot of Python scripts now appearing on the web. A lot of people use spreadsheets. And then we also at the University of Idaho have the RefiT software is still available. Here's a QR code if you want to take a screenshot. It's a free software to use that can kind of guide you through entering the weather data from files or spreadsheets and making the calculations. Louis already talked about QAQC. That is so important. We cannot underemphasize or overemphasize, excuse me, the importance of having good quality data to calculate good quality ETO and ultimately crop evapotranspiration. So this is just showing, like Louis showed, a before and after, top and bottom. And the corrections can be simple if it's just due to a pyranometer miscalibration or drifting of the calibration. Here, we multiplied some days in the first year by 1.4 simply and elevated the measured data up to the clear sky curve. Second year by 1.16. So these are determined, they can be determined automatically, these adjustments using that theoretical clear sky curve, that blue line. It's just based on geometry. Part of that RefiT includes a QAQC application that follows all of the procedures of the FAO 56 as far as providing for a fairly easy way to visually assess the data fairly quickly. It's not a big chore, and it can be quite enjoyable to see the data visualized. And then we can employ some automated correction within the software. So here's an example of the spreadsheet that QAQC application can produce. Just a nice long chart showing all of the data, in this case for the solar radiation. So one can very quickly scan years of data within 5 or 10 minutes and obtain a good assurance that the data are good or to indicate that there is some correction needed or replacement needed. Here's something that I'll talk about a little bit. Another chart created in that spreadsheet. And of course, you can create these in any spreadsheet or using Python software, other software. This is just showing what it looks like when we plot daily maximum air temperature with minimum air temperature, the brown line, and with dew point temperature, the blue line. And what we want to see for calculating ETO is we want to see data that behave like they should when there's a nice wet transpiring surface underneath, like the clipped grass that we hope to see in our weather station sites. And in this case, we can see pretty much every day that the dew point does tend to float up and down very closely to the minimum air temperature. And that's what we expect, because at nighttime, the temperature of the air should cool down close to the dew point if there's sufficient humidity in the air from local and regional transpiration. And then wind speed, there's not much we can compare to, but we can just observe that the anemometer looks like it's freely turning and operating, and we have a good consistent year-to-year and day-to-day variation in wind speed. What we really want to emphasize in the revision, and we emphasized it in the 98 version, but we're emphasizing even more now. We appreciate the encouragement of many of our international colleagues, including Dr. Henk de Bruin from the Netherlands. He's been quite adamant in the importance of local surroundings being wet and humidified and cooled before we utilize an equation like the Pima-Monteith. So we want to collect our data, if at all possible, from something that looks like on the left, that's green and transpiring, and not on the right. Just kind of a wordy slide that kind of gives the reason why. The Pima-Monteith is a physically derived equation. It only requires that we measure air temperature at 2 meters above the surface. We don't need to measure at the surface. That's the contribution of Penman in this combination. However, because of the resistance settings that are in the Pima-Monteith for the ETO reference, as Lewis pointed out, that equation expects that the air temperature and the humidity data are produced from a surface that is evaporating and transpiring, so that there is surface cooling occurring and humidification of the boundary layer up to the 2 meter height. That's required, for one, for the calculation of the delta term. The Penman equation assumes that the air temperature is similar to the surface temperature, so that only mean air temperature need be used to calculate delta, the slope of the saturation vapor pressure curve. And if we feed the FAO Pima-Monteith data from a hot, dry surface, it confuses the equation. It's instructing the equation to estimate ET from a surface that has no ET. So the air temperature and humidity data are not synchronized with the ETO estimate that we are attempting to derive, and the result is we will overestimate. Therefore, we need to adjust data if we feel that it has some arid behavior. This is just a quick little slide showing what we're talking about. This is showing temperature on the right and vapor on the left profiles over both a dry surface and wet surface. And over a dry surface, our surface temperature might be 10, 15 even 20 degrees warmer than it would be over a transpiring surface. And then as that profile goes up from the surface to a 2-meter height, we still have a substantial difference in measured temperature over a dry surface as compared to a wet. And again, the Pima-Monteith formulation is expecting that we are over a wet surface with that cooler temperature when it's parameterized to calculate ETO. Same with the vapor profile. It'll be much more humid over a transpiring surface, of course. And so we want to be measuring a more humid parameter at 2-meter height. So something we've done hopefully a bit more robustly in the revision, but we've attempted to still keep it simple, is to make an assessment of how well our data seem to adhere to data collected over a transpiring surface. And so this top equation, similar to what I just showed in that graph of the temperature plots, there should be some consistent relationship between dew point temperature and minimum air temperature, minimum daily air temperature. And the separation, of course, should be expected to grow as we go into an arid region because our air mass is quite dry. And so we should always expect up to 4 to 6 degrees Celsius separation between T-dew and T-min in a very arid region. And as we get down into the more subhumid regions, it's very common to see dew every night, which means that the difference between minimum air temperature and dew point should be quite close to zero in most conditions. That aridity index, we've chosen to use the kind of international WMO standard Thornthwaite approach that just looks at the ratio of annual precipitation to a Thornthwaite climatic evaporation index, just to get an idea of the general wetness of the climate overall and the likelihood of humidification of the atmosphere. So the adjustment, this is just one of several that we are proposing in the revision, but it's a simple adjustment on purpose so that people shouldn't have difficulty making it. At the top, like we've been looking at, we evaluate a difference between min and dew point temperature, usually on a monthly basis, just to kind of average out general trends. And then we can make a correction to the max and minimum air temperature by taking the observed values and then subtracting off the amount of that delta T that's in excess of that AT target that we showed on the previous slide. And BT is just a partitioning between the adjustment to the air temperature and then the adjustment to the dew point that's at the bottom of the slide. So we both cool down the air temperature and we increase the dew point so that it more reflects the T-min, T-dew separation that we would experience over a transpiring surface. And then that can be applied daily or even hourly to data. And finally, concerning the use of gridded weather data sets, they're becoming more and more common and available, freely available. They have a lot of advantages of providing us spatial information on ETO over large areas and over large, long time periods. So their use is not discouraged in the revision. However, we want every user to be sure to provide QA/QC to all of the data in those gridded data sets. Make sure that the solar radiation does not have some type of systematic bias, and that the air temperature and humidity data do not have an aridity bias, which they often do, because many of the weather forecasting models that create these gridded data sets ingest data from very dry weather stations, including at airports, other places. Many of those models do not really see the input of irrigation, so they don't realize that there is as much, that there is very little or very much ET. They rely only on rainfall for input. So in a semi-arid, arid region, they will estimate a very low value of ET and elevated temperature as compared to what one will experience if one is irrigating in that region. So there's a large likelihood that one should be applying these aridity adjustments to gridded weather data. Here's just an example of the difference in vapor pressure in kilopascals that is measured at the top in the green over an irrigated area in south central Idaho, where I'm from, as compared to the same vapor pressure taken from a gridded weather data set called NAR in the US. And we can see a lot of correspondence between the two data sets. However, over the irrigated area, the vapor pressure is almost double, twice as much as what comes out of that gridded weather data set. So it's a real mistake to use that gridded data to estimate ETO without some type of adjustment for the aridity of that data set to make it useful. So I'll quit there, and thank you very much.
Thank you, Professor Richard, for your presentation. I will now introduce our next speaker, Dr. Paula Paredes. So our next speaker is Dr. Paula Paredes from University of Lisbon. She has been conducting research on crop water requirements, water modeling, and irrigation scheduling using real-time data and weather forecast. She has also been working on crop growth modeling and water productivity. She is the author or co-author of 82 Scopus indexed papers. She is also associate editor for a few journals. She has contributed to the development of the soil-water balance model, which adopts the dual crop coefficients approach. Professor Paredes, if you are ready for your presentation, feel free to start.
Okay, so good afternoon, everybody. First of all, I wish to thank Professor Paredes for inviting me to this webinar. And I want to thank also Water for this initiative. I want also to greet my colleagues in the panel and also all the audience that I hope they can enjoy our presentations. So today I'm going to focus on the novelties in the crop coefficients and their determination. So the single and dual crop coefficients in the revised version of the FAO 56 guidelines are focused on chapter 6 and 7. So as previously told, the FAO 56 approach uses the reference crop evapotranspiration that we heard from Professor Allen, and then it evolves to use the crop coefficients that combine the characteristics of the targeted crop and change the reference evapotranspiration to our new crop. So this is when we have well-watered crop and optimal agronomic conditions. When we have environmental stresses, then we have an actual crop evapotranspiration, and associated to that, the actual crop coefficients. So when we want to talk about having a good estimations of crop evapotranspiration, we have to focus on distinguish standard and actual crop evapotranspiration, and associated to that with the crop coefficients. When we have those environmental conditions that are targeting our crop, then we have that actual crop coefficient, So we have to emphasize a lot relative to this, because when we are at the field, we are always talking about actual conditions of the crop. So when we want to use the crop coefficients, we have to know exactly how our crop will grow. And only if we know that information, and then we have a good accuracy on determination of the evapotranspiration. So moving from the FAO 56, we have to describe well the crop coefficients and the curve. So we have the initial crop coefficients, the mid-season crop coefficients, and the end-season crop coefficients. With those three values, we are able to build the segmented curve of the crop coefficients. So during the initial period, soil evaporation will be the main for most crops, of course, will be the main component of the evapotranspiration. So it will be linked with the frequency of the wetting events. When the crop develops, then it will be during the mid-season, it will be linked with the crop type. So the characteristics of the crop, if it's annual, if it's a perennial, it will depend on that. And then during the late season, we have that the management of the crops will be the most impactful one relative to the values of the crop coefficients. So we have two approaches that can be used by users. We have the single crop coefficient, that it's best for the annual crops or the crops that completely cover the soil, and then we have the dual crop coefficients. Normally, it is used for the incomplete cover of the soil, for woody crops, and also for the mulched crops. So because we will have a higher impact on the evaporation coefficient. So we have to determine correctly the crop coefficient. So here are two examples of good accuracy for one on the left side, you will have the vining peas that are for the industry, and they were well managed. And then on the right side, you will have for an olive orchard, where we have a good accuracy also using the measurements of the soil water balance. So here we have another example. It's an hedgerow olive orchard, where we have a deficit irrigation during the summer. So if we have deficit irrigation, then we will have a crop coefficient that is lower than the standard one. In this case, we also consider, since it's a woody crop, the non-growing and the growing period. So you will have also water use even during the non-growing period. So we have to focus and to note that when we have crop coefficients, basal or single ones, that are tabulated in FAO, they are transferable because they are standard ones. They are not. They were not developed under stress conditions. So it is associated with crops that are developed under non-stress, well-watered, and highly productive conditions. So in this revision of the manual, we have for the annual crops, because then Dr. Ramon Lopez Ojea will talk with you about the orchards. I'm going to focus more on the annual crops. So we have divided the vegetable crops according or group the vegetable crops according to the edible parts. So we'll have a group on roots, tubers, bulbs, and stems, and then we'll have fruit, vegetable, leaves, and flowers, and then we have a completely new group that is spices and medicinal herbs. So this is a major improvement relative to the original file 56. Then we will have also the field crops, where we have grain legumes, olive crops, fiber crops, sugar crops, and then another one that is the bioenergy non-edible crops. And then we also have the cereal and pseudo-cereals, and we have also rice. Rice is apart from the other cereals because it has a completely different management, as you know. Most of the rice is flooded, but nowadays the technology is improving, and we are seeing now that it's advancing also for sprinkler, and in some parts also it's being drip irrigated. So as you can see, we have numerous new crops that we have included, and then you can see when the manual finally reaches. So we have the single crop coefficients for the 3 stages that I told earlier on. And then we also have indicative values from the maximum crop height and maximum root depths. We now introduced a large number of grasses, particularly those for forage and also grasslands, and also for landscapes, including the sports, so for golfing. So this is an innovation relative to the original version. And then we also have other 2 groups that include the wetlands and riparian plants that are nowadays very useful for environmental impacts assessments. So this being said, we tabulated the crop coefficients, not only the single ones, but also the dual ones. But we have to remind that these crop coefficients, these tabulated crop coefficients, were developed for subhumid conditions. So we have to adjust to our local climate conditions the crop coefficients for the mid-season and also for the end season. So here you have an example. Sorry. So this is for the end season. So we have to adjust according to the conditions, the management of the crop. So if it's harvest earlier or not, we will have different conditions in terms of soil moisture. And also it will impact the crop coefficient for the end season. So here are also the tabulations for the dual crop coefficients. We have the same grouping that I told you about previously. And in this case, besides the maximum height, we also give you some indicative values of the maximum ground cover fraction. So it's the fraction of the soil that is covered by the crop. And this is a useful information because later on we will talk about the new A&P approach that Professor Pereira told you earlier today. So one of the most innovative things of this new version of the FRAU 56 is the definition of the KC curves using thermal time or growing degree days. So we had a very huge revision of studies that were applying growing degree days, and we found out that it is necessary to use this approach, especially when we are dealing with the climate change scenarios. So this is very useful for us to know how the crop will develop according to the temperature in the air. Of course, this thermal time approach it's based on the development of the crop is linked with the temperature. So the grain degree days is based on the lower limit and the upper limit, and we use the mean temperature, so the average between the maximum and the mean temperature, daily temperature, and we compare it with the base, the lower limit, so the base temperature and the upper limit of temperature. So as Professor Pereira was saying, and he showed you this example, if we are in different countries in the world, we can have different spans of the crop season. So this exercise was made with maize. It could be with other crops, but what we did is to use the growing degree days approach, and we estimated the duration of the crop cycle. In this case, it ranged from 85 days to 140. And the previous tabulated values that were just for information ranged between 125 and 180 days. So this is a good improvement. But nonetheless, we always keep saying that people should observe it in the field. This is very important because even the growing degree days will change according to the varieties and new cultivars. So for the thermal time calculation, we have tabulated the limits of the temperature, so the base and upper limits, and we did it for numerous crops, also for annual and for perennial ones, and Dr. Ramon Lopez Rey will tell you a little bit about it later on. So, and we also tabulated observational cumulative growing degree days for a set of crops. As I told you, these are indicative values, but can be used with some degree of confidence, of course. So here is an example for maize cropped in the southern hemisphere. So in Brazil, in two different sowing dates. So one on 15 September and the other on 15 October. And you can see it's very obvious that you will have different crop cycle when you sow in different dates. And then the FAO 56, the new revision, also deals with the determination of the actual basal crop coefficients using the ANP approach. So this is a very easy to use approach, particularly for implementing on the day-to-day irrigation scheduling advice. So we just need to have two observations, the crop height and the fraction of the ground cover. You have some examples on the right side for you to see. So we measure the fraction of ground cover and we measure the height, and then we have parameterized the other non-measured variables that are linked with the stomatal control and with the canopy density. So based on this, you can use the ANP approach and then to adjust to your local conditions, because this was parameterized using the standard crop coefficients. So here you have two examples, one that is from California in the United States, and we can see that the ANP approach it's very good. And here are two other examples. Professor Pereira also have shown you for onion and tomato. Here are other two examples of this of the application of this approach against soil lysimeter measurements and also soil water balance computations. Thank you very much.
Professor Paula, thank you very much for your presentation. I will now introduce our last speaker, Dr. Ramon Lopez Urrea. Dr. Ramon Lopez Urrea has obtained his PhD in agriculture engineering in Spain. He is currently research scientist with the Desertification Research Center in Valencia in Spain. His expertise include determining crop evapotranspiration, the optimization of irrigation scheduling, and improving water use efficiency and productivity in farming systems. Recently, he has focused on remote sensing-based phenotyping methods to assess crop evapotranspiration, biophysical variables, and the water status of vine grapes. During 2015 to 2017, he was the director of 2 Spanish research and extension institutions. Professor Ramon, if you are ready, you can start with your presentation.
Good afternoon, everyone. Firstly, many thanks to the organizers for the invitation to participate in this event. It's a pleasure for me to take part of this webinar along with my colleagues, Professors Pereira, Allen, and Paredes. And I also want to thank all the people for attending. Well, my presentation focuses on the work carried out in recent years in regards to updating and completing the single and basal KC for fruit trees and vines. And as you know, in FAO 56, there was a lack of information regarding the crop coefficient for many fruit trees and vines. And when this information became available, it didn't take into account the different type of orchards and vineyards that can exist for the same crop. I mean, the different canopy covers, age, plant density, training system, crop height, etc., etc. Since 1998, hundreds of articles have been published about producing crop coefficients, making it absolutely necessary to update and complete the information reported in FAO 56. For that reason, now in 2025, we're updating this information, and the updated FAO 56 single and basal crop coefficients are based on 3 review papers recently published in the scientific journal Irrigation Science. Okay, as Professor Pereira pointed out in his presentation already, FAO 56 proposed to distinguish between standard and actual crop ET and KC. The standard refers to pristine well water conditions, I mean non-stress crop conditions, healthy ground crops which attain high or maximum yields, or eustress conditions. Eustress refers to meal to control water stress that may favor yield quality, and also can lead to small water savings. It may be particularly interesting for tree and vine fruit crops, which are often subjected to control and regulated meal water stress. Okay, but in practice, however, many fruit trees, orchards, and vineyards are managed under suboptimal conditions due to water stress, soil stress, non-uniform irrigation, irregular plant density, inadequate soil management, cultural practices, or other factors. Under these circumstances, the observations refer to actual crop ET. And I would like to highlight that transferability of crop coefficients only apply to standard conditions. Well, now I'm going to say quickly the 3 review papers used to update the new information about crop coefficients. The review articles published in Irrigation Science had the objective of updating available information on standard single and basal KCs for tree and vine crops, and were used for supporting the relative tabulation of updated crop coefficient values now published in the revised version of FAO56. They focus on three main climates: temperate, Mediterranean, and tropical. And the selection analysis of the literature were performed considering only studies that follow the FAO56 approach. Well, the first review article I'm showing here in this slide, the first review focused on the result of single and basal crop coefficient of woody crops carried out over the past 25 years and focus on Mediterranean and warm temperate fruit trees, And the crops included in this review article were table and wine grapes, olive and citrus orchards, and warm temperate crops such as avocado, loquat, persimmon, and tree crops. The second review article provides an overview of the research has been periodically carried out since 1998 up to 2024 on KC and KCB values for tropical and subtropical orchards. The crops included were all these, cactus, pears, dragon fruit, fig trees, jujube, passion fruit, etc., etc. And here the most important, I would like to say that most of them were not included in the original version of FAO 56, published in 1998. And finally, the third review article focused on updating crop coefficients for temperate climate fruit trees, vines, and shrubs. And the crops included in this review article were palm fruit trees, pears and apples, stone fruit trees, apricots, cherries, peach, nectarine and plum, nut trees, almond, hazelnut, pecan, pistachio and walnut, and vine crops and berries, specifically kiwi fruit, hop, blueberries, and 3 different species of blackberries. Well, and now I'm going to show some main novelties or new aspects in the updated of KC and KCB for woody crops. For me, the first new and interesting aspect is that many fruit trees and vines crop have been included in the FAO 56 revised version. Specifically, in FAO 56 were reported crop coefficient for 21 woody crops, and the revised version of FAO 56 contain information on 58 fruit trees and vine crops. The second novelty and very important aspect is that FAO 56 revised reports single KC with consideration of the fractional canopy cover, plant density, training system, crop height, and age. For example, here in this slide, you can see for almond trees, a distinction is made between young, low degree of ground cover, medium, high, very high, and heatstroke super intensive. In addition, ranges of the maximum fraction of ground cover and maximum plant height are presented here in these tables. Well, the same information presented for single crop coefficient is also presented for standard KCB values, and as well as relative to plant density, training system, degree and fraction of ground cover. Here, for example, in this table, you can see the olive orchard, where a distinction is made between young, traditional non-irrigated, traditional non-irrigated medium density, intensive, low density, super intensive, medium density, and super intensive, high density. I mean, we are providing much more information to calculate crop ET accurately. Finally, another novelty or new aspect that is included in FAO 56 revised has been pointed out previously by Dr. Pereira, Dr. Paredes. The new FAO 56 revised uses the thermal time or the growing degree days to estimate the crop growth stage length. To this end, a table is presented with the base and upper limit temperatures for GDD calculations. Comparing with the original version, here as everybody knows, in FAO 56 was presented the length of growth stages in days. And for example, for almond trees, a fruit tree, a nut tree, this information was not reported. However, now in the revised version, as you can see in this slide, the cumulative GDDs required to complete each crop growth stage is reported, differentiating between two types of season, early and late maturation. Finally, I would like to, we in the revised version acknowledge the contributions of all these people, and I would like to highlight the contribution of my colleagues, Dr. Paco Montoya and Dr. Luciano Mateos, that sadly passed away about 3 years ago. And I also want to thank my institution, the Certification Research Centers in Valencia, Spain. And thank you. That's all for now. Thank you. Thank you for your attention.
Thank you, Professor Ramon, for your presentation. So we have a lot of questions in Q&A box. So I will now read the questions and I will ask you to answer on them. So the first question is for Professor Richard. How FAO 56 can support improvement growing crops of wheat, tomatoes, and cucumbers?
Okay, that's a specific question. Regarding the reference ET calculation, I think the improved treatment of aridity can give us a more precise and accurate estimate of ETO and the evaporation demand of these crops. So we can help farmers do a much better job of precision irrigation on them. For example, in the case of cucumbers, which can have a fairly shallow root zone, it's very important to apply adequate water to them to reduce any stress on them. And I think, you know, these are with all crops, the better the estimate of the crop coefficient using the dual KC approach so that we can better account for the consumption by evaporation from the soil, again, will help us manage a more accurate dosage of water to these crops. Thank you.
Okay. Thank you. Thank you for your answer. Then we have a question, I think that is for Professor Luis. Are there any values of KC established for vineyards? Are there variation with latitude?
Okay. This reply is related with the presentation that colleague Ramon already did. And we have these observations for both table grapes and wine grapes. Question is that it is not related with the location. The KC are related with the crop. Eventually, they can change a little bit with the weather when they are to go to be applied. Oh, but they are effectively transferable if they correspond to the standard conditions. It means that this KC corresponded to observations in fields that were very well cultivated, that could achieve a good, very good yields, that did not show any kind of problems, of stresses. And this is the way how the KCs have been developed some 50 years ago by already disappeared friend, Professor Marvin Jensen. This question relates with another that I have seen, but not in questions, but in comments, that there is one colleague that says that crop coefficients are not that good. They are, and of course, they are not that good, okay? But the problem is the size of that. Is that good very far from good or very close to good? In my opinion, after, I don't know, some 40 years working on this subject, I find out that unfortunately, we are not able to produce better results with the techniques when we are in application. The perspective is different. They are effectively not that good if we are just studying in research about the way how the crop works, how the plants work, how the cells work. This is not a good approach. We have to find out other approaches. Thank you.
Thank you, Professor Luis. The next question is how to consider GDD for KC in case of crops which has multiple cuts like alfalfa in a growing season. So this question is not directed to a specific speaker. So does any of the speakers have an answer?
Yes.
For Paula.
I can take the answer to that. Yes. First of all, as I told you during my presentation, we have to go to the field and observe. That's the main issue. Then the second, we can use the grain degree days to use for the cutting the different grasses, and we can use it and to determine how many days we have to have between cuttings. And we did some work with some colleagues in Santa Maria and in Brazil, where they cut the grasses using the thermal accumulation. So when it reached a threshold, they cut the grass, and they tried to estimate the amount of biomass that was accumulated. So that's a very interesting thing to do when we don't know exactly the number of days. So we use the growing degree days, and we have the tabulated the upper limit and lower limit of the temperature, where it starts the development of the crop and when it reaches the maximum of the accumulation of biomass. So it can be done. I hope I replied to the question. If the person who did it wants to contact me, it's okay, and we can share other comments. Thank you.
Okay, thank you, Professor Paula. And however, the next question is also for you. I don't know if you already reply. However, the question is,
I don't know.
If you need to simulate a mixture of annual crops, 2 crops, for example, how do you think it will be useful to calculate the summary of degree days, given that base temperatures are different?
Oh, no.
If you have 2 crops, so you have intercropping, probably. That's I think it's I interpret the question. So if you have an intercropping, you will have different managements of each crop. So you have to do the cumulative growing degree days and to study the curve, the KC curve, for each one individually. And then we have an approach that it's the use of the intercropping crop coefficient, that it's also detailed in the revised version of FAO 56. And there's a chapter where this is well detailed, and how to convert the separate crop coefficient curves for each of the when they are single cropped into one that it's the intercropping. So I hope again to have answered the question, but once again I'm available to reply
Okay.
to other.
Thank you, Professor Paula. The next question is about estimation of trees IT0 using KC values. In the most of the natural situations in peri-urban regions, many different tree species are grown together. So what is a guideline to estimate AT using such KC values in such complex environments? Are KC values available for all trees types?
Trees. You want?
If I understand well, the question is if you have different, in the same plot, you have different managements of different plant densities, different fraction of farm covers. This is the question?
It
Yes,
seems like it's a landscape. It seems like it's a landscape where you have different kind of. I suppose that's my interpretation of the question. So where you have different shrubs and different trees, I suppose it's that they are requesting. I don't know. Maybe the person who did can send again some clarification on the question, please.
I have to say one thing about the problem that we have is that the KCs are developed for large areas with uniform crop. So when we get the applications of KCs to small plots, we have immediately a problem of changing the aerodynamic conditions out there. So immediately there is a change that we don't know immediately. If there is a mixture of high crops with small crops, but I say I can be a palm tree and another tree can and a small tree below the palms. Of course, there are approaches for computing and combining the computed values for both types of trees. So this is the same for combining, for instance, maize with green beans. Okay, this is difficult. And this difficulty is solved characterizing well each crop, when one develops, when the other develops, when one shadows the soil or one shadows the other crop. This is to be constructed, let's say the answer is constructed by looking careful the crops. So this cannot be given in a table, and so this, only the essential part of this can be given in the guidelines of FAO. Okay?
Thank you, Professor Luis. We have another question for Paula. How crop evapotranspiration can support improve food security in countries with desert and arid climate?
That's a hard question. Food security, well, if well managed, the crops, then you will have achieved high yields. But what we are targeting here is to have a tool that supports farmers and technicians to better irrigate. So if the irrigation is well performed, then you can achieve good yields and also to save water. And this is a major issue in those kinds of climates. This is a general question, so a general answer, more or less.
Yeah, but if I can say, in the new FAO 56, there are new ways of computing the radiation, the incoming radiation, because here these dirty conditions in the air affect essentially the radiation, not the crop, of course, but and we already placed some, but there are references to other kind of studies on radiation in conditions different from common.
Is that all, Professor Luis?
Yeah.
Thank you. Thank you for your answers. The next one is there any data can be downloaded for penman method? So this question is not directed to a specific person. If you do have answers, we can skip. However, Professor Luis.
Can you say again?
Is there any data that can be downloaded for penman method?
No. No. We abandoned the Penman method. We keep considering excellent the Penman-Monteith method. That is a very special approach, not similar to the use of the crop coefficients.
Okay, thank you. Then the next question is for Dr. Richard. When deriving the actual crop coefficients using the energy balance method, is there a way to account the lateral heat flow?
That's kind of getting off into measurement, but hopefully there's not substantial lateral heat flow over like what Lewis described, a large uniform field. We should have an established equilibrium boundary layer so that the primary gradient of heat is nearly vertical coming from the air or to the air. If we do have lateral heat flow, that means we're in kind of a clothesline type of condition, and we shouldn't expect the standardized crop coefficients to apply directly without some type of adjustment. And if we are measuring ET where there's lateral heat flow, we may be violating some of the first principles of eddy covariance and Bowen ratio monitoring. So it's just good to be careful. It's good to bring in some micrometeorological experts when setting up equipment and making an assessment of the site and the quality of the data collected to make sure that it is representative.
That's okay.
Just one comment on like the challenge of intercropping and like cutting dates with forage crops. Hopefully the transition to growing degree days will help with the cutting of the forage crops. If we go into a cool period or a warm period, the thermal basis should help us to account automatically for that so that we don't have to manually stretch lengths of stages, and we can rely perhaps less on direct field observation. And with the intercrops, hopefully the functions that we have for estimating KCs for different densities of crops, we intend them to be fairly simple and visual so that the user can visualize what he or she are wanting to estimate as far as the size of a plant, the density of the plant. And so it should provide some comfort and ability to make these applications with some degree of confidence and the ability to just make a practical assessment on whether it makes sense and is intuitive. Thank you.
Thank you, Professor Richard, for your answer. So since we go 10 minutes over time of the webinar, I would like to kindly ask all participants to send their emails and questions on email journal.webinar@mdpi.com. Since we need to finish with the webinar for now. So we will also leave the message in the chat so everyone can find email where they can send their questions, and we will try to reply you as soon as possible. So before we close the webinar, I would like to thank you to all participants and also to chair and speakers for their presentations. I hope the participants find the presentation interesting. Please note that certificate of attendance are available for all registered participants on our SciForum dashboard. Also, I would like to invite everyone to take a couple of minutes to complete our satisfaction survey by following the link provided in the chat box. Your feedback is important for us so we can improve our future webinars. Once again, I would like to thank everyone, and to close this webinar, I wish everyone a nice day, morning, or evening, whenever you are in the world. That will be all from our side.
Have a nice weekend. Bye-bye. Thank you.
Thank you.
Bye-bye.
Thank you.
Thank you all.
But
Bye.
I would like to ask to say that our email addresses and so on are known for sure through the MDPI and through yourself including, and we can be asked for whatever you wish to. We also point out one thing that is for the next future. We did what we had possible to be accurate, rigorous, and so on with our FAO 56 revised. But we need that the people that uses this information perform their own tests and eventually publish these results that they obtain, confirming or putting or questioning what we did, because it's only by a progress in knowledge that we can effectively arrive to conditions where water is saved and yields are increased.
Thank
Very
you,
good.
Thank
Professor
you,
Luis,
Luis,
once again for
and all.
chairing this webinar.
Bye-bye. Thank
Thank
you.
you.
Thank you,
Bye.
everyone.
Bye-bye.